66 million years ago, our world changed forever. A massive asteroid hit, completely wiping out the dinosaurs. It was the ultimate reset button, permanently reshaping Earth's evolutionary trajectory in the absolute blink of an eye. Now, we've all heard this basic childhood story, right? Asteroid hits, dinosaurs die, extinction happens. It's literally one of our very first lessons in natural history. We've seen the dramatic movies, we've read the textbooks, and for years we just kind of accepted this narrative as a straightforward, done-deal fact. In our minds, that asteroid was always just a generic, giant boulder, a massive, ordinary rock falling from the sky that brought an entire era to a screeching halt. Just a global mass extinction with a seemingly simple cause. Okay, let's dive into this, because how much did we really know about this apocalyptic rock before now? Until today, we only had the basic picture. Sure, we knew its rough size, and we knew exactly where it landed in the Gulf of Mexico, but the specific identity of this doomsday rock, that was basically a blank space in our scientific understanding. We just sort of assumed it was ordinary space rubble. But the truth? Well, science has just opened a window that completely flips this mystery on its head. Scientists have just discovered a groundbreaking, highly specific detail about this particular asteroid. And let me tell you, this is no minor update to the historical record. It is a massive twist in a story we thought we knew inside and out. We are moving way beyond the broad strokes of a generic space rock. Researchers have completely rewritten our understanding of Ground Zero, finally identifying the true nature of the dinosaur killer. It's an absolute game changer. So what did they find? Well, it turns out this was absolutely no ordinary space rock. This asteroid belongs to an incredibly rare classification known as a CO chondrite. When scientists analyzed the chemical breakdown of the microscopic debris left over from the impact, they were stunned. Being a CO chondrite means its chemical composition is highly unusual. It carries elements and ancient materials that you just don't easily find, even across billions of years of cosmic history. It was a wildly unexpected, extremely specific type of rock that literally changed everything. Now, what's really interesting about this is that the asteroid's incredible rarity and its unique chemical fingerprint point to a highly unusual cosmic event. When a CO chondrite hits Earth, its very presence is a massive signal. This rare chemical signature tells us flat out that its origin point was anything but normal. This wasn't just some random stone that got bumped out of a nearby asteroid belt. No way. This was a unique visitor, with a fingerprint proving it came from a very distant, very unfamiliar place. Let's move on and see how this builds, because this thing didn't come from our cosmic neighborhood. By tracking its chemical signature, we can actually map out the asteroid's epic journey. It formed in the extreme outer edges of the solar system, out in that freezing, dark void millions of miles away. From there, it traveled a truly massive distance. After drifting through the cold emptiness of deep space for millions of years, it finally crossed our path. It's just mind-blowing to think about the massive cosmic scale it had to cross just to reach the world it ultimately destroyed. So that brings up the big question. What actually happened immediately after the impact? We've tracked this rare rock all the way from deep space, but what did Ground Zero actually look like when it finally hit Earth? Let's shift our focus from the massive scale of the solar system to the immediate, terrifying planetary aftermath. How did the specific chemistry of a rare CO chondrite completely change the mechanics of an extinction? And this brilliantly illustrates the shift in our thinking. We used to assume the aftermath was just standard rock debris and smoke. But this new discovery reveals that the composition of the dust and debris was completely different than expected. Because of the asteroid's unusual chemistry, it created a toxic, rare chemical blanket. The unique elements of that CO chondrite turned ordinary rock debris into a deadly cocktail. The sheer physical scale of the impact was huge, sure, but the most dangerous part was the fallout. That specific chemical release turned a standard asteroid strike into an unprecedented toxic catastrophe. This microscopic chemical data reveals exactly how the dinosaurs went extinct. That toxic blanket didn't just stay local. It spread globally, wrapping around the entire Earth and entirely blocking out the sun. And we are not just talking about a cold spell here. This was a rapid chemical deep freeze that locked the planet in ice. With sunlight completely cut off, photosynthesis stopped almost instantly. For any animals that miraculously survived the initial shockwave, they were met with this harrowing, terrifying deep freeze that shut down every path forward for life. It was a total, fatal chain reaction. So why is this specific 66 million-year-old story currently the #1 trending topic being discussed this week? Because it introduces a completely new, incredibly specific twist to a historic event the whole world thought they understood. It's a major breakthrough delivered through microscopic, irrefutable data. So the crucial point is that this discovery doesn't just confirm the old story. It reveals the exact real-time chemistry of that fatal day. By analyzing those microscopic dust particles, we can now reconstruct the fallout as it happened. We can deeply understand how that toxic blanket formed and how rapidly it choked out the planet's warmth. It's an absolute masterpiece of modern science, a technique that gives us a direct front-row seat to that catastrophic day with a level of clarity we never thought possible. Which leaves us with this provocative final thought. If a single rare rock from the extreme outer solar system could change Earth's chemistry so drastically, what other ancient secrets are still hiding out there in deep space? Today, we saw how one lonely rock had the power to hit the reset button on our entire ecosystem in a flash. It really makes you wonder just how many other world-altering chemistries are floating around in that cold, dark, uncharted territory. Keep wondering about that, and I'll catch you in the next explainer.